This is a simple AC circuit, part 1 equation. Now, what is simple AC circuit? AC circuit is a circuit in which alternating current flows. I repeat, AC circuit is a circuit in which alternating current flows. Then what is alternating current? We say that alternating current is the current that changes direction periodically. These currents are produced by alternating voltages. The symbol for alternating current is given as this. This is the symbol for alternating current. So wherever you see this, it means alternating current. Alternating current is given, alternating current and alternating voltages are given as shown below. This is alternating current, while this is alternating voltage. In this alternating current and alternating voltage, I here, this I means instantaneous current, and I naught means peak or maximum current. And this one means phase angle, and this phase angle is measured in radian or degree. This V here means instantaneous voltage, and V naught means peak or maximum voltage. This file here also means phase angle. But you notice that alternating voltage corresponds to electromotive force or potential difference, in the sense that V is equal to this, V naught is equal to this, then E is equal to E naught sine phi. This one is called instantaneous EMF. That is what this equation is called. And this E naught means peak or maximum EMF. So we can get this where this phase angle is given as omega t. I can call this equation 4. This is called equation 4. By the time I substitute equation 4 into equation 1, equation 2, and equation 3, I'm going to have this. I can call this equation 5. I can call this equation 6 and equation 7. So this one, having substituted this one into these equations, I will now be able to generate equation 6, equation 5, equation 6, and the equation 7. So I can now say recall from equation 4 that, recall that phi, which is the phase angle, is given as omega t, which is angular velocity times time. This angular velocity is measured in radian per second and is given as. So by the time I substitute this into this equation, I'm going to have this to give me 2 pi ft. This is called 2 pi ft. I can call this, this is 2 pi ft. So where f is given as 1 over t. So substitute this into this equation, I will have first angle to give me 2 pi t over t. I have 2 pi t over t. Then we saw, notice that but 2 pi is equal to 360 degree. So wherever I see 2 pi, I will put 360 degree. This equation becomes this. Phi equal to phi equal to, this equal to 360 t over t. This is a very nice equation. I can call this equation 7. Equation 7. So if I make t here the subject of the formula, small letter t, I will now have that this phi is equal to 360. It's also the same thing as t over t. These two equations are the same. But what I'll now do is that t over t, where t over t is number of cycles. It's called number of cycles. So by the time I substitute this one into this place, I'm going to have this to give me 360 degree times number of cycles. This is equation 8. Okay, I call this equation 8 as the number of phase angle. So take note, this equation is very, very important. We are going to use it to solve a lot of problems in this topic. So from equation 7, I have that phi is equal to 360t over t. By the time I make small t the subject of the formula, I'm going to have t is equal to phi over 360 or into t. Call this equation 9. This equation is also very important. You will see the application of all these equations in part 1 calculation. That is where you see all those things being applied. Then I call this equation 7. Then I'm going to generate a table of value for this AC circuit. The table of value for this is this, where I have, this is phase angle measured in radian. This is phase angle measured in degree. Then I have, t is equal to, I say t is equal to phi over 360 into t. Then I have this one. I'm going to have I, knowing fully that I is I naught sine phi. I'm going to have V, which is V naught sine phi. Okay. Okay, now let us proceed. This place I have 0. I have pi over 2. I have pi. I have 3 pi over 2. Then I'm going to have 2 pi. This place 0 here is 0. Pi over 2 corresponds to 90. Pi is 180. 3 pi over 2 is 270. 2 pi is 360. Now, this file is in degrees, meaning that we are considering this. By the time I substitute 0 into this place, divide it by 360, and multiply by t, I'm going to have 0. 90 here, divide by 360 is 1 over 4 times t, that is 1/4 t. Put 180 here, and divide by 360, multiply by this, you're going to have half t. Put this into this place, you're going to have 3/4 t. Put this into this, you're going to have t. Then, I naught sine phi, this file is in degree, so sine 0 is 0. 0 times I naught will give you I naught. Sine 90 is 1. 1 times I naught will give you I naught. Sine 180 is 0. 0 times I naught will give you 0. Sine 270 is minus 1. Minus 1 times I naught will give you minus I naught. Sine 360 is 0. 0 times I naught will give you 0. Likewise, this place, you're going to have the same thing. 0 V naught, 0, negative V naught, and 0. This is the table of value for this. Then you're going to plot a graph of, we're going to plot these two, instantaneous current and instantaneous voltage, against time. By the time I do that, I have this, can have this, can have this. So this is IV. Can call this place I naught, call this place negative I naught. I'll call this place I'll call this place V naught. I'll call this place negative V naught. So this place is 0, 0. Then I have 1/4, 1/4 T. I'm going to have here as half T. I'm going to have as 3/4 T. I'm going to have this as T. And this is T axis. Now watch. I'm going to plot this now against this. When I is 0, T is 0, which is somewhere here. When I is I naught, T is 1/4 T, meaning that it's like this. If you trace it, you're going to have it somewhere here. When this one is 0, this is half T, which is here. When this is negative this is this, you're going to have it negative of I, which is trace it like this. You are going to arrive at this. So when this is 0, you have T, which is this place. So this is a sine waveform, which is going to be like this, and like this. So this one is for the current. This is I into I naught sine phi. Also, you are going to plot this against this. This is 0 and 0, which is same here. V naught and 1/4 T, which is here. If you trace this like this, you're going to have it here. This is 0 and this is this, which is here. And this one is negative V naught against 3/4, which is somewhere here. If you trace it, if you trace like this, you're going to have it here. Then this is 0 by this, you have it. So this one becomes, for this one now, you're going to have this. So this one is V equal to V naught sine phi. So this is the waveform for instantaneous current and instantaneous voltage. But the distance from here, if you trace like this and trace like this, we have something like this. The interval, I can call it A. This A now is called peak. This is called peak from here, from this place to this place. The interval there is called peak to peak current, because you are dealing with current. If it is from here to this place, you call it peak to peak voltage. So this is how this one is being done. Now let us see current root mean square. Let us see current root mean square. That is the root mean square value. Current root mean square or voltage root mean square is the current or voltage that produces the same heating effect in a resistor as direct current. So I said current root mean square or voltage root mean square is the current or voltage that produces the same heating effect in a resistor as direct current. So current root mean square is written like this. Current root mean square is this, and is giving us peak current over root 2. This can also be expressed as 1 over root 2 or into peak current. And the 1 over root 2 is giving us 0.707 or into this. So this is the formula for current root mean square. Voltage root mean square is giving us peak voltage over root 2 which is 1 over root 2 into this, and that is 0.707 V naught, where V naught is the peak voltage and the I naught is peak current. So this is where we're going to stop for this. Then what you do is that you visit part 2. This is part 1 equation. So you visit part 1 calculation. We are going to employ all these formulas I've derived here into that place. Thank you and remain blessed.